Good morning dear students. Today I am going to discuss about the capacitance of parallel plate capacitors. What is parallel plate capacitors? The simplest and widely used capacitor is parallel plate capacitor. It consists of two large plain parallel conducting plates separated by a small distance. In this diagram we are seeing that two plates of the capacitors is kept separated at a distance d. One plate has positive charge and another plate has same amount of negative charge. A is the surface area of the each plate plus q charge is accumulated on one plate minus q charge is accumulated on another plate plus sigma is the surface charge density on plate on positive plate minus sigma is the surface charge density on the negative plate. At the intermediate region between these two plates has uniform electric field and the electric field is fringing at the two open sides of the plates. We are also seeing that the net electric field is 0 at the region 1 and at the region 3, that is outside the two plate, but the uniform electric field is exists at the intermediate region between the two plates and which has value E equals to sigma by epsilon naught, where epsilon naught is the permittivity of free space. Because the space between the two plates is filled by air. If this space is filled by any dielectric material, then the net electric field at the intermediate region between these two plates will be E net is equal to sigma by epsilon naught and sigma by epsilon, where epsilon is the permittivity of the dielectric. So in outer region left or right of the plate, the electric field due to two charge plate is 0, but in the inner region between the two capacitor plate the electric field is add up and the net electric field is sigma by epsilon naught. If the area of the plate is very greater than d square, then there are uniform electric field between the two plates, otherwise there is fringing of the electric field at the two open side of the plate. So potential difference between the two plate of the capacitor is electric field into distance between the two plate, that is V equals to E into D. If we are putting the value of E, we get V equals to sigma by epsilon naught into D, and this implies that V equals to sigma D by epsilon naught. This is the equations in air medium. By definition of the capacitance, we have C equals to Q by V. This implies that C is equal to Q epsilon naught by sigma D. If we put sigma equals to Q by A, we get C equals to A epsilon naught by D. Sigma here sigma is the surface charge density, that is charge per unit surface area. So this is the equations for the capacitance of parallel plate capacitors when the space between the two plates of the capacitor is filled with air. If the space between the two plates of the capacitor is filled with any dielectric materials, then this becomes C equals to A epsilon by D, where epsilon is the permittivity of the dielectric. Thus the capacitance of the parallel plate capacitors depends on following factors. From the formula of the capacitance C equals to A epsilon naught by D, we can tell that the capacitance depend on following factor. Number 1 is area of the plate, that is C proportional to A. C is directly proportional to cross-sectional area of the plate. C is also inversely proportional to distance between the two plates, and C is also directly proportional to epsilon naught or epsilon. So C equals to A epsilon by D is the required expressions for the capacitance of a parallel plate capacitance when the space between the two plates of the capacitor is filled with any dielectric medium, any dielectric